Hello, everybody, and welcome to this amazing exercise in which we're going to create this super speaker Wi-Fi speaker. What's going to be interesting in this lecture is how we're creating just a concept model. Concept model, what does that mean? Here, there's nothing inside. It's just a paper model. With everything what we create here, that's kind of like a sketch on paper, just an idea of the shape without all the interior stuff in it. The way how we will start and work is by bringing in first a canvas, scaling it, creating then just only the sketches we need. And then I will show you an interesting mix of surface and solid modeling techniques to create all the details we have here. For example, this stuff here in the center looks highly detailed. That's actually easy peasy kindergarten stuff. My 5-year-old could do this. Okay, so with all that said, let's do it. So we start with a new scene. Also here, right click, turn off the design history. Millimeters we keep, very good. And then let's go to canvas. The download link for the image is inside the description of the video. I have this here. There it is. Bring this one in. Font is on Behance. Thank you for the person who provided it. And there we are. Okay, good. Now from the bottom to the top, that should be around 11 inches. So before I continue, you see I'm in millimeters right now. Doesn't matter actually much. You can go to calibrate. Then here on this grid line that makes sense, it's easy to follow. Then I go up. So roughly here. There. 11 inches. Fusion is then converting inches into millimeters for me. Right click, edit canvas, move this to wherever. And then we try to center this, trying to find an object that's not too big, easy to center, kind of like this piece here. And I'm using the grid to eyeball this. Very good. We're not making a manufacturing model of this. We're just using this to study how to surface. Cool. Okay. There is the sketch. Now, again, this is going to be a concept model. This is not a manufacturing model. It's all the speakers and the inside and how all these parts are connected, we don't create. Specifically at the beginning of when you design a product, everything that goes inside is not yet really that important. I mean, you know what should go in, but you're more concerned about the styling of the outside, the look, the feel, the interaction, the proportions, and then we put all the electronics in and hope everything fits. So what we can do is identify easy to redraw lines. Let's start actually with this piece. So we'll learn a lot about sketching today in this exercise too. So a new sketch on this view, and then we will go to the spline control point and start somewhere here. Click, and I know I need another point there. And I'm paying attention to how this curve grows. There seems to be a kink. Then I need one here. I need one there, one there, one there. And then here it stops. Okay, good. Do I know if all these points are correct? I have no idea. I might have to move these around. And in case the prediction is not correct, I might have to redraw this spline. So keep that in mind. What we can do now is, you see with all these points, I can select, regroup, position them, and then start massaging the curve to kind of like following this outline. When points get close together, I can start pinching a curve, by the way. If points get further away, I'm flattening a curve. Here, these 2 points I want to be vertical. I can select the low polygon or the control cage line, make that one vertical, and then these points are always vertical. That's important for tangency. Tangency because, woo, how this one flows down should continue flowing into the bottom. This point actually is good, so I lock it. I don't want this to move anymore. And now I'm simply scrolling around, trying to see what else can I do here. This is not really possible to, with the few points I have here, to super good rebuild the shape, but yeah, I think we can say I got pretty close. Yeah, there. Okay, let me show you something interesting. So right click on the spline. Nope, that's not the menu I want. One more time. Right click on the spline. Toggle curvature display. Yeah, what's this? No? Let me go back. And I create another spline here, there, there, and there. You see how this is very long? Here, 2 points together. It bends quicker. When I just do 3 points, now it looks this way. And now I am going to be super silly. So, smart working, opposite working. Right click, curvature graph. You see how crazy that is, and when I move 1 point, you see how the graph changes. The graph basically defines how quickly a surface bends. The more the red line is away from the spline, the more the curve bends. See, when I get this closer or flat, if I make this all flat, there you can see how I get these divots out. Here, for example, I only have 4 points. Oh, look how smooth this is. And 3 points. Yeah. You can see this. What I'm trying to show you with is, if you pay attention to the red graph, you can see that the lower line is nice and smooth, and the other one has like way too much caffeine. So that's also a very good point about too many points is too much work and the surface later will be terrible. You want to work with the least amount of points to force the curve into the shape you want. Sometimes you need a few more points, but when I, for example, start removing these points, cleaning this up a little bit, you can start noticing how this can get actually more even. There. But you see now it's still, for example, here this is very long. And here, because I have 1 extra point, and maybe at the start 2, I can in general have from the beginning already a nice curve. And here this is more linear, then it bends, and then it's linear. Okay, well, maybe I can remove 1 more point. Let's see. Yeah, it's also not too bad. Okay, good. So that about how many points I have here. Is this necessary? So I could, with what I said, try to see, can I remove a few points and move this around? Yeah, you see this point I was able to remove. And now this looks actually pretty good. The rest is pretty much, I think, I can't remove anymore. That's what I need. Okay, very good. Right click. Nope, one more time, right click, turn this off. Okay, so this part is done. Very good. Congratulations. Now, down here, one could say straight line down and then a line maybe to here. Okay, and then this point here with M, I move down there. Look at this. Okay, and then I can do a fillet. Yeah, but the surface this command would create is G1 is not very interesting and kind of terrible. So how can we rebuild this with a spline? Start point, 1 point for tangency, 1 point for tangency, end point. and you think I'm speaking a foreign language, that's okay. This might take a moment to understand what we are doing here. So this is the tangency. There's the next tangency, and there I stop. So I select this line, bring this to there, bring this to there. Yeah, what you see here from there already starts flowing down way too much. So, right click, insert spline point, maybe there. I needed another control point. Yeah, and maybe I do the same here. Right click, insert spline point, maybe there. Okay, good. So, a little bit of cleanup. These two lines I would like to be vertical. And then these two lines I would like to be parallel. Then this point I move to here. Fix it. And now, basically, when I move this point, you see how the midpoint, this is a straight line. And with this, I can control a straight line and a curve. And here, this is a top one. With this, I can bring this line down. And with this, then I talk about when that bend starts. Yeah, look at this, no? It's not 100% precise. Again, this is just an image, and everything what I'm trying to show you all here is actually how this surfacing works and working with curves and splines. Cool. Okay, so that's good. This is an interesting piece which we will deal with later, but for the moment I will do this in a simplified way. So maybe like this. Okay. And then here we have an arc that goes up. I will use the fit point curve. I could have used an arc too, but I'm trying not to spend too much time on modeling this for you. And then we can here go up, go over. There is now an arc. So I will start putting a line down there. Sometimes Fusion creates artifacts. There was an artifact. And these points here I lock. It's horizontally. And now to put in a perfect arc, point to point circle. Click, click there, and then trim, get rid of this. And now this arc is tangent, not tangent, it's 90 degree here. No? So perfect. Things that I want to move is, for example, this point here. And now here we have a nice dome. Let me show you how we can model a dome that is, yeah, only half part built. This is a construction line. Lock it and make construction line. Then we go to control point, click, tangency point, and click. And now we can say U to U tangency, and point, pay attention to this point, tangency to there. So when I move this point, you see how this vertex goes, and you see how they're connected. So now I can sculpt actually my curve quite nicely. And when this rotates over or mirrors over, it perfectly continues. Well, we made actually really good headway. Perfect. Nice. This piece we did here. Let's do one more time, actually here. Roughly here I draw a line. This line lock and construction there. Thank you. And then we, in this time, for example, we can use an arc. Go to here, and then there's the arc. So you see the arc is now tangent applied to that line, but should not be construction line there. Maybe a little bit up. Very good. Right click, curvature display. You see the arc is very even? Well, because it's a circle. And the line, well, it doesn't bend, so you wouldn't see anything. This point is good. Let's lock it. This point, I mean. Thank you. Then we have something that comes down here. We can easily do this with a fit point curve there. Why? Oh, this is always turned on by default. There, thank you. And then we can move this around and try to make it match. It's a hard connection here, perfectly fine. It's actually good. Or if we want to make this a little bit nicer, good, here. This might be a good control point. Click, tangency point, curvature for moving it, and endpoint. So now tangency, so you go tangent to there. And you see now how there's a little flow. When we zoom in there, you can see it goes in. And then with this, we can sculpt this more nicely. Yeah, I like this more. Cool. Here's an S shape. That's interesting too. Control point. What's really important is like, I'm actually building this kind of here. Yeah, click. Then I go horizontal. I go down and I go horizontal. I want this line and this line to be horizontally aligned. So when I drag it or I move one point, you see it all adjusts evenly. There, look at this. There's our flow. Cool. Pretty good. Yeah. We actually made really good headway with everything what we have here. So this piece here we need to refine. We can select a line from here. This line maybe can go down at an angle like this, 3 millimeters in, and then we use a fit point, click, click to do an arc. I used the fit point curve to do arcs, which are not 100% a clean arc. These parts are a little bit faster than this bends more like a circle, and then this is faster. It's a matter of preference. This line here, actually now I delete, which, yeah, and then see here we have this little dip and can say, hey, start point and end point horizontally. So we make actually sure that this line is equal. Escape. Let's turn this off for the moment. Yeah, that actually looks pretty good. So this means we can now go ahead and do actually some surface tests. So here's my Revolve command. And there's something going on here right now. You see when I click on this, everything is selected, but chaining is turned off. Normally what should happen is with chaining off, only one piece is selected. In case at one point somebody sees this video and this bug is fixed, there you have it. So axis, here's the axis, and now, whoa, we can do a revolve. And I'm actually on purpose going on 180 degrees. So I can look into the piece. No? That's why. That's pretty cool. Okay. Yeah, that works. So let's continue. Sweep. Nope, not sweep, sorry. Revolve. I am in this case now selecting this, and this. Let's say that is actually the speaker, the membrane, 360, perfect. Repeat. There and there, and then I select this one, yeah, axis, there, very good. You might ask yourself, hey, why didn't you do this one? I will come to that in a moment. Then this and this. Actually, I can select all three at the same time. 360. Okay, good. I did all those 360 because that's what I want to see. Here, this one I kept half, so you can see inside. No? Okay. So this surface here, we don't need anymore. Let's go revolve you along the z-axis 360. Thank you. And now we're going to give this a material thickness. Inside 4 millimeters. Very good. We can't really see inside, so let's turn on section analysis on this plane. We might have to flip it. There we are. Yeah, it went to the inside. Very good. Thank you. Very nice. Okay. This is actually too tall, and we might have to split this. Turning off all my surfaces, right click, edit this sketch, and from here I'm going to build a new line. Now this is a helper line. I will revolve just this piece. Yeah, there will be an arrow, all okay, because the bodies are invisible. There we are. Okay, so this surface I can use to split. So body to split by this surface. Thank you. This can go. And now there's my lower part. There's my upper part. This piece does actually not touch it. Oh no, I didn't model accurately in the sketch. Yeah, it's okay. That's a cool thing what I'm showing you in this video about surface modeling. We can extend the surface a little bit. There. Whoop. I don't really know how much, maybe. Could be there. I go to there. Thank you. Now, I will go and say trim, and I will select this inner face of this solid, and then I click on this extra piece that sticks out. And okay. And the red piece now is gone. So we selected this face and decided, hey, be like a scissor, like a cookie cutter, and cut the outside away. And that was it. Quite simple. Well, what else can we do now that's easy? So that is done. We could, for example, to be really done here and here. 2 millimeter, okay, 1 millimeter. Now we round this there. So the subwoofer, that is finished. This piece, yeah. So we have this unstitch, 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 unstitch. Very good. Thank you. So then this piece is alone. And what I will do now is you and you stitch together into one piece. By the way, everything that's gold here should be silver. So I do this with the reverse normal command. Cool. Okay. That piece I want. So gone, 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 and gone. And I turn analysis off. The bottom I will cap. Thank you. Then I will stitch this together. Thank you. And then the bottom I will extend a little bit. Thank you. Okay, now check this out. I will create myself a construction plane from the bottom a little bit above, -50 in this case. New sketch on this. Turn this one off so we don't see this. And there's now my center. I will go and select my arc tool, and then I don't know, maybe I could also maybe do this from here. Yeah, let's see. Okay, yeah, maybe like this, who knows. 2 millimeters. Okay, very good. Thank you. Then I will go ahead and say, please project this edge in and this edge in. Thank you. Cool. So what can we do now? Fun stuff. We will now select this and extrude it into the body. How far, how deep, no idea. Just eyeball it, do what I do. Again, this is just a paper model. This face we're going now to push back by 1 millimeter. So looks like 55. Yeah. And then here, that face we push back or push inwards, so 36 millimeters. Very good. You notice now that we actually switched from surface modeling to solid modeling. Oh, what is going on there? This is terrible. Wow. This thing here shouldn't be there. So let me do one check. Yeah, it is tangent. So this arc is tangent to here, so it should be good. This pointy highlight feels like there's a pinch. Anyway, let's ignore it. Solid piece is done. Now I want to make all these other pieces by hand. Of course not, that would be insane. We just select the circular pattern tool. 60 patterns, please. Thank you. And then the browser is blowing up. It's okay. We select then the base, go to the side view. Yeah, right to left click. Do not keep tools, click OK. Bonk. There. See? I mean, this is not exactly the piece that I have in the design, but with this exercise, I wanted to show you how we can create these structures. Via surface modeling, that would be a pain in the you-know-what. And with solid modeling, that was super easy. So, surface modeling. Yeah, well, we can delete these faces we don't need by simply pressing delete. Ta-da! Yeah, cool. I want to try something out. I delete this, then I go to patch, click this, say patch, and I will set this to G2 or G1. I go with G1. You see actually that it nicely domed it. So basically it came with this curvature and then it continued it. I like this one more. Okay, you're cool. You can stay. Good. Done. What is this? We don't need this anymore. I think. Yeah. This is finished. Yeah, the feet. To the sketch. This is going to be an interesting challenge now. So I sketched something here in because I have the speaker. And you see, it's not really matching it. But again, very, very simple design actually to solve. You see here, we see actually the side view. So in sketch 1, I will go back. Then here is a horizontal line. Okay, thank you. And then spline point, click horizontal and down. Okay, so you see I built a little bit over. Tangent, yeah, this is good. I then do not need anything else. So check out the rest, what I'm going to do now. This is actually really interesting. This piece, I extrude both sides really far. Okay, it's going to be a cutting tool. Then I have now here my leg. So that segment I would like to revolve. this one, please. Axis here, but not 360. They are 3 feet, so 120. There we are. Okay. This whole thing, however, needs to be centered here. So 120 divided by 2. No, so reposition the rotation to there. Click, click, done. And then you can see at what point is this centered. Looks like at 30 degrees. Yeah, so not 60, 30. Yeah. Good, I'm not teaching math. Then you see this line is slightly under this line. That's perfect. So we can do trimming now. So let's go trim. This is our trim tool, and then click this. Woohoo! It cut it away. Pretty awesome, no? Yeah. How do we do the other side? So we can go ahead, mirror this body along this plane. So there I made a copy of my cutting tool. No, you are the cutting tool, and then there we cut this away. Very good. Should something maybe not work. Before we do the cut, we can also do an extend. So I'm just extending this. I have to do this here anyway. Why? Because I need to fill the space in here. No? So see this. When I click trim on this, click this. Yeah, something doesn't really work. Yeah, what do we do? Essentially, all I want is just cut along here and then cut along this three-dimensional edge, but I don't have anything here. So I can create this. Bottom view. New sketch, there. Then from the center, one line. And another line. And a center line. And be careful about all these little Fusion. I drew too fast and Fusion cannot follow lines. X, construction line, these two will be what degree? Correct, 120, which whoa, I nearly perfectly hit. And then 360 divided by 3, 120, this 2. So now we have 120 slices. Oh, look at this. It perfectly lines up. Man, do I like geometry. I guess that's why I got into industrial design. Chock, 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 trim tool, boom, done, finished. Okay, now you see this is actually like mass production now. Trim, click, 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 click. That's the beauty of surface modeling. Now, I learned this with Rhino for years till I got frustrated with Rhino being really weak at fillets, etc. Alias is also great, but you don't want to learn it. It's way too complicated. And this is actually super comfortable and easy. We have some terrible edges there. So let's go to fillet. Now we can also fillet surfaces. No, it doesn't have to be solids. So the process pretty much is the same. That's the beauty of it. 0.5. Yeah, this looks better. The radius here changes in a really terrible way. So I will switch this to chord length. Now you can see there, it looks exactly the same way there. My name is Klaus Kuhnen and I approve this fillet. Cool. Okay. Working smart, not hard. One of the biggest tips I can give you, we made one piece and now we use the pattern tool to not make 60, but 3. Ta-da! Look at this. No. Click, click, click. Join. You shall be married. There. There, 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 there. there, there, there. Yeah, look at this. Pretty awesome. Where's our analysis? Here. No, that's actually pretty nice. So maybe the last piece is to add an interface element. So we will create a construction plane. Doesn't matter if you go front or back. I mean, technically speaking, should be to the back. 120 is, yeah, in front of it. So new sketch on this one. There we are. And then here with a line command, click and drag, click and drag and close. Then we want to do the tangency. There we are. D for dimension. That's 20. Okay. Right click. Select the tangency command. 70. Okay. Height-wise, where is this positioned? Who knows? This is not that important, but what's important is here. We want this to be centered. You see how I drew a line? X, vertical line to the midpoint. It's perpendicular. Very good. So this piece is indeed now centered. I could now, if I want, for example, this arc, project into this sketch. Thank you. And then with D, add a dimension, 15, let's say I should be 20 centimeters off this edge. No, easy peasy. Cool. This bottom line we don't need anymore. Yeah. Cool. Okay. Beautiful. So what do we do with this thing? We would like to have a lip going around 5 millimeters. So offset command -5 in this case to the outside. Awesome. Now actually a really fun process is going to happen. Surface, extrude. This piece I would like to extrude as a surface. So 9 millimeters, then it touches it, 12, then it's really inside. Let's give this 5 more millimeters. So in my case, -17. Okay. I'm just unhiding everything what I don't really need. There we are. Whoa, where's the, there, cool. So, beautiful. So what can we do now? So this whole piece should have a lip, which is trimmed by this. So what I'm going to do now is the following. I will do an offset of this surface by 2 millimeters, so it's bigger and easier to see. Very good. Then this body I hide for the moment. Thank you. And now, trim command. This surface trims this off. Okay, trim command. The sketch trims this window here off. Okay. Trim command. The sketch trims the outside completely away. Oh, you? Go get a coffee. Then where is the rest? There's the rest. Okay, and then there you can see now how this sits in front. Very good. How do we fill this gap? Let me show you the best and clean way. So I'm extruding a new surface. Okay. Then this cap cuts this. Thank you. Right click. And this cuts this. Sometimes Fusion doesn't know what it wants. Thank you. So there's no this something else present. Yeah, okay. And there you can see. So, and then trim, we say this piece trims this inside open. Yeah, look at that. Now you see how we build actually these surfaces. Cool. I hope you, like with this exercise, started to see how elegant actually this method is. Reverse, there. Patch. With patch we can fill this inside. Thank you. Just a simple G0. So positional. Very good. Click, 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 click. You, I shall rule you. I'm a robot from space. No, 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 no. You are a super speaker, and we shall give you materials now. Okay, very good. So, to the materials. Before we do this, we can clean up all this feature nightmare here. Fusion Browser and direct modeling is really the best therapy for people with cleanup issues. It forces you to clean up. So, press A for materials. What do we start with? Maybe we can go with plastic. And then I scroll down, opaque, and I have here a glossy. The glossy we might maybe use for this. Okay, good. And then we have a matte. We can use the matte for the rubber. And here, this I hide for the moment. Then this I would like to be that glossy. This I would like to look like aluminum. So I go to metal, aluminum, maybe this brushed one there. This can be glossy, then this will be matte, more like a fabric. Okay, very good. Oh, hello there. Glossy. Silicone. Now I see I'm not being super picky with the materials. Fusion has a render engine built in. It's well, don't use it. It's okay for screenshots, to be honest. Actually quite good because you can work in one environment, model and take screenshots of the renderings, but it's not really that good for final renderings. It's not made for it. And that's also okay. That's why we have Blender. Then let's go to plastic one more time, and then we will go to transparent. Close. Okay. The only thing that's now missing, for example, are interface elements. Now you could go Google the PNG with a transparent background, for example, of power on, Bluetooth, telephone, and loudness, lights, etc. What's really cool about this speaker is it has a light built in. And we have a logo here. The logo and all these things we can put in as a decal. A decal is kind of like the term for sticker. There is my logo, super speaker. It wants a surface. There's the surface, and then I can rotate it. There you see, move this up and down, make this maybe smaller or bigger. The quality of the image, how many pixels you have is really important. Yeah, and there we have the super speaker Wi-Fi speaker that will soon light up during the night in a different video. Okay, that's it.